Most of the issues I have with this machine relate to the controller, and there are a number of them. First of all, I noticed that the front and back panel, which are made of fairly thin metal, tended to bulge out, and when you pressed on something they would move. So I've added an additional screw both front and back to stick that onto the plastic behind to make it a little firmer. The second issue was that all of the external metal, the front panel, the back panel, the base plate and the top, when it was originally metal, are not grounded, which is of course in violation of most countries' electrical safety laws. So I've used these front and back and bottom plate screws to ground the metal panels, which I'll show you in a second. One of the things I changed fairly quickly was the top panel was originally made of metal, but inside the unit there are several indicator LEDs, and of course you can't see them through the metal panel. I thought it was a waste having all those status LEDs without being able to see them, so I had a plastic company bend up a sheet of acrylic plastic in the shape of the top panel to replace the original metal one. So here we have my top made of acrylic plastic, so you can see all of the insides, and for example at the back you will see the ground lug in the middle of that white plastic piece here, which I've added to the screw which I've used to tighten up the back panel, and likewise there's one on the bottom panel screw down in that bottom corner there, and all of them connect to the terminal block down the front here, which fortunately contained 3 terminals, one of which originally wasn't used and is now my ground terminal, the middle terminal. Of course I used the CNC3040 itself to cut these slots, ventilation slots in both sides of my Perspex cover, using a simple little 3-line subroutine called 25 times to cut the slots. Another issue with the control box is also to do with electrical safety. All of the connectors at the back are male connectors, which means there are pins sticking out, and if the sockets are not plugged in, even with the spindle switch off, the spindle pins can be live depending on which of your incoming lines is active, because the original spindle switch was only a single pole switch. This is very dangerous. In fact, I received a shock when I was plugging in the XYZ connectors and my hand grazed against the pins, the exposed pins of the spindle socket. So those rear sockets should in fact be female and not male, but I don't propose to change those. What I did instead was fit double pole switch for the spindle so that both lines are isolated regardless of which one is active. The additional advantage of that is the switch can be illuminated so that you know when it's on. The drive switch I didn't need to change because the drive switch turns on power to the 24 volt power supply, which itself is isolated, so it was not necessary to isolate both mains lines. However, just for appearances I've also changed that to double pole illuminated switch. You'll notice also that my speed control is on maximum and I switch the power on, but the spindle is not running, as you can hear. That's because of another modification I've done. I was unhappy that when you press the emergency stop switch the spindle kept running. Mark III would, which I'm using as my drive software, would stop the drive motors dead, but the spindle kept running because Mark III had no control over it. So what I've done is made a change to the spindle drive board you can see the little piece of Bureau board, prototyping board, in the back corner with a green LED on it. There's not much else there apart from the connector and the optional green status LED. There is just a optocoupler integrated circuit and 2 resistors. The green LED is a status LED which tells me that the computer has killed the spindle. The spindle is not running and won't run as long as that green LED is illuminated. If I press the F5 key on the computer, that light will go off and the spindle will run. This is going to be a bit tricky with me holding the camera. You see the LED is now off and you'll hear that the motor is running. Press F5 again and it stops. Very simple modification, just 2 wires soldered onto the board from my added scrap of Vera board, plus the connection across to the computer interface board, where I've added a 4th connector for the spare channel. So they have the XYZ channels there already. I've used the A channel as my spindle controller.